Hey everyone, it's Joe and welcome to another video for RAD103. This is Module 3 and we're looking at Lecture 4.1. We're going to be discussing Digital Image and Equipment QC, and we're also going to get into Exposure Index and Deviation Index. So let's dive right in. So I'm going to start this lecture by discussing Exposure Index and Deviation Index. And I've mentioned before that with digital imaging, you can't determine whether or not you use the right technique simply based on looking at the image. That's not correct. But with film, this was a whole different story. When you didn't use the right technique with film, you got a poor image, and so you would have to repeat the X-ray. That's not the case with digital. And as we've mentioned in the previous lecture, that the software programs that we have, the algorithms and the lookup tables that the computer uses to make an image will make corrections or subtle changes to make your image look proper. So you can't just look at an image on digital and say that my technique was great. You have to look at something called the exposure indicator or deviation index. So the definition of an exposure indicator is a quantitative method expressed as a numerical value to estimate the radiation exposure received by the digital detector of the image acquisition. It's not the exposure to the patient, although they are getting exposed more or less depending on your technique, but this is the exposure indicator is how much X-ray actually hit the plate, not necessarily the patient. Now, the first company to come up with an exposure indicator was Fuji, when it realized that, yes, when you look at the image, it looks perfect. And so how is it that we show the technologists that their technique was too high or too low, and that we helped them with that because of the software? So Fuji came up with the sensitivity value, or S value. And I think I know I've mentioned it in class, but the exposure indicator for Fuji is inverted, which means that, you would think that a high number on their exposure indicator would represent a high exposure, but that's not the case. A high number represents a low exposure, so you didn't use enough technique, and a low number, like something around 50, would mean that you overexposed it. So this is a little bit different. I'm not sure why they decided to do that, but most exposure indicators are going to be proportional. So if it's got a high number, you have too much exposure, you have too much radiation hitting the board, and if you have a low number, you have not enough X-ray hitting the board. So let's talk about some other examples here. Now, as you can imagine, different manufacturers are going to have their own exposure indicator. Canon has something called the reach exposure values. GE has the digital exposure indicator. Fuji has the S value. But there are some people like Carestream, they use exposure indicator. They don't call it anything too crazy. And so just as a background, because we have so many different type of exposure values or names of those exposure values, there was a group or a committee put together in 2009 to try to standardize everything. It didn't really work out that well. As a matter of fact, I think they are the ones that ended up coming up with deviation index. But let's take a look at some of examples of different manufacturers and how their numbers are related to exposure. So here I've got a list of different vendors, and we can see that if we look over on the right, the optimal range or the numbers that they use is different depending on several different things, depending on manufacturer. Sometimes it's going to be different depending on the body part that you're exposing X-ray to. So it's kind of interesting how they're all over the place. The other thing to note is that the only value that's inversely proportional is the Fuji S value. So again, if I have an S value of 700, that means I underexposed the plate, not overexposed. And if I have a value of 100, that means I've overexposed the plate, not underexposed the plate. So to me, that's very confusing, but if you're used to it, you get used to it. Everyone else is directly proportional. So a higher number means overexposure, a lower number means underexposure. But you can see here that there's different values all the way from, Canon uses negative 0.5 to positive 0.5. We've got GE, which it's going to vary by body part. So a chest X-ray, you look at the ideal chest X-ray should be between 0.2 and 0.6, where an abdomen could be 0.56 through 1.68. So doesn't seem to be any kind of standardization here, which can be confusing to people. But like I said, when you get used to your system, it's pretty easy to deal with. But the fact is, there's a numerical value somewhere on your control panel showing you whether or not you over or underexposed your image plate. Now, when dealing with exposure indicators, there are some things that come into play that you have some control over and some things you don't have control over. One of them is going to be collimation. If you do not properly cone for your exam, then you're going to expose too much of the plate, and that's going to raise your exposure indicator. So you're going to get a higher number. If the person is a bigger person or a smaller person, so if you're doing a hand and this person is, kind of a blue collar guy who works with his hands all the time, it's big and, it's a very muscular hand, that's going to eat up more x-ray, and maybe that's going to affect the exposure indicator. Bigger thighs, bigger knees, bigger hips, they're all going to take away x-ray from reaching the plate, and that'll lessen or decrease your exposure indicator. If a person has an implant, such as an artificial hip, that hip is going to absorb a lot of the x-ray, and that's going to bring down your exposure indicator. And the last thing is, once again, SID plays a role into this. If you have the incorrect SID, or if you're not putting the technique appropriate with the distance that you're dealing with, that is going to affect the exposure indicator. That's going to affect how much x-ray ends up hitting your plate. So keep those 4 things in mind when you're looking at your exposure indicator. You might have had, you've got a properly positioned patient, you coned in correctly, but there's an implant and everything else is correct. Well, you're going to have a low exposure indicator, but there's nothing you can do about an implant. So just keep that in mind when you're looking at your EI values, what might have affected it when you see the result. Now, deviation index is a real simple way of determining whether or not you have under or overexposed your patient. It takes away all of those different numbers that the different vendors are putting out there. They all have to use the same type of deviation index. And really what it comes down to is a scale going from -3 to +3, with 0 being right in the middle. 0 would represent the ideal technique used for that patient. So if you get a deviation index and it's 0.0, you hit the nail on the head. That is a perfect technique for the patient that you did. There's proper coning, no issues with hardware inside that patient's anatomy or whatever. You get a perfect image. And so that's what a 0 would indicate. Now, if you go to the plus sides of things, that means you're overexposing the patient. So if you get a deviation index that's +1, let's say, that means you're a little bit overexposed. You probably used maybe 25% more exposure than you needed. You still got a nice strong signal. It's probably a very good radiograph. But next time you do this, maybe decrease the mass a little bit. You've got a little too much exposure. So as you're getting into the pluses, yes. So +2 means, that's a lot more exposure. It's another 25% on top of that. So you're using more technique than you really need. And if you're a +3, that's excessive. Now you've doubled the amount of mass than you needed. You really need to make an adjustment to your technique, or change what is popping up on your computer when you decide to do that type of exam. So when you get up to +3, things need to change, whether you as a technologist or the actual control panel itself. Obviously, the flip side is when we get into the negative numbers, that means you've underexposed the patient. So -1, it's probably still a good image, but you probably should use a little bit more technique. Maybe the computer had to work a little harder to get that image to be nice and uniform. So -1 is probably still acceptable. When you get to -2 and certainly -3, you're probably looking at quantum model at this point. You certainly didn't use enough technique at all. And so I bet you have a speckled appearance type of image, and you probably have to repeat that exam. The good news is it was an underexposure, so the patient didn't get as much x-ray, but you got to do it again. So that's what deviation index is. Not all manufacturers make it easy to find a deviation index, but they should all have it on their equipment. And it's up to you or the manufacturer to ask to say, I want the deviation index to be on it. I know I've seen it on the Fuji portables that we have with the Beverly system, but I have not seen deviation index with the Carestream equipment. But check out your equipment, see if you can find deviation index. It might be in there. So I've mentioned collimation recently about how it's important to collimate appropriately, because that's going to bring down your exposure index. I've also mentioned collimation with regards to developing or the processing of your image. If you've not coned well enough, it's going to throw off your histogram. So collimation is an important part of being an x-ray. And I wanted to mention something called dose area product. What dose area product means is that it's taking into consideration your collimation when dealing with, let's say, exposure index, or if we're dealing with dose. So the dose area product looks at or understands how much you've opened or closed your collimation by having sensors underneath the shutters in the collimator box. And so when it determines what the intensity was or the dose for the patient was, it's going to take that into consideration. Every time you see a result that shows, I'm looking at the bottom here, the dose area product is measured by the device collimators below the collimator shutters. It measures the dose area product in grays, or usually milligrays because we don't use that much dose, milligrays per centimeter squared. So whenever you see something with centimeters squared, that means it's taking into consideration how much you've collimated. And collimation, like I said, can affect the image a great deal in your exposure index. The more you collimate, the less dose that patient's going to get, the less dose the x-ray plate's going to get, and so dose area product plays with that. If you're doing an abdomen, you're going to have a large dose area product because your x-ray field is going to affect the entire 14 by 17 portion of the plate. And so that would have a high dose area product, so the centimeter squared is going to be a lot higher, and that is indicated with your dose area product by looking at how much of the plate is being exposed. Now, after talking about this, a few people asked me what air kerma is. Air kerma is the ionization in the air going from the tube down to the plate. So how much radiation is in that air going towards the plate. Now, your air kerma is going to be also determined by your collimation. So if you have it wide open, you get a wider area of air kerma. There's a wider swath of air that's got radiation in it. If I've coned down, I'm going to have a more narrow beam of radiation, and that affects how much air in that area is going to be affected by radiation. So air kerma of the X-ray beam and the volume of the X-ray beam. The volume is your collimation. So hopefully that makes sense. If not, let me know. And with that, I'm going to stop here for now, give you guys a break, give myself a break, and when we get back, we'll talk a little bit more about quality control and quality assurance of the X-ray equipment. See ya!